You ready to do some math? I think you need another nap. Hey guys, it's me again. It's time for 10.6 writing numbers and scientific notation. So yesterday we wrote them from standard form into scientific notation, and today we're going back from standard form back into scientific notation. I have some new ears on today. I have Sorcerer Mickey and then Steamboat Willie Mickey. They're custom made. I got them off of Etsy. I got 3 pairs of them. Oh, you know, I can show you them. Peter Pan! And then I got, you can't see him through the cellophane, but I'm not going to tell you who this is. Let's see if you guys can figure out who this guy is. Oh, I guess I should probably take it out of the bag. But anyways, so hopefully yesterday's video helped you out a little bit. Hopefully today will go as well too. Today's probably going to be longer because I do have 4 examples to get through. Just the first part is taking your number that's in standard form. Standard form, remember, is the way that you guys are used to seeing numbers written, and writing that into scientific notation. I also found a really cool video that I used to watch, actually, as a student on powers of 10, and so I'm going to post that as well. It's from, I think, 77, I want to say. So it's older than dirt, pretty much. And it kind of just gives you an idea of what something with a power of 10, how small and how big it can be. And it gives you examples. So it's pretty cool. So hopefully you guys like that. I'll be posting that as well with this video today. So here we go. We are going to go standard form into scientific notation. And then I have some examples of when we're going to compare numbers in scientific notation today. Talking about the dinosaurs and that kind of thing. So Mr. Campos, if you're watching, hopefully you can help out some kids. All right, so example 1. You are going to write really large numbers in scientific notation. Now, I'm just reading the example in the book. It says a large corporation purchased a video sharing website for... Now, if you look at that number in the book, I wonder how many of you guys could read that. Because if we were in class, I would have you guys read that. And you guys would be like, You'd pause, you couldn't quite remember, but it's actually 1,650,000,000. So write inside not. Okay. Right, in scientific notation. And we're going to go 1,650,000,000. That's a big number. I wouldn't even mind having that many pennies. So we're going to write this in scientific notation. So remember, your power does 2 things. It tells you which way to move the decimal, and it tells you how many times. So depending upon if the power is positive or negative, that would tell you where to go when you're writing your numbers in scientific to standard. But with here, you've got to think about, how is this number compared to your factor C? Well, here we go. Remember your C. So we have to go C times 10 to the nth. That's what we're looking at today in our form. That's how we have to write this. And remember, your factor C has to be greater than or equal to 1 and less than 10. And so the first thing you do on this problem is you got to figure out where your decimal is. And it's all the way back here. And then you're going to move this decimal until you get to a number that is, for your C factor, less than 10, greater than or equal to 1. And so if I moved it this way, I would just be getting farther away. So I've got to move it in. And I'm going to keep going. And in class, I would have you guys tell me, can I stop? Can I stop? Can I stop? And I can't stop yet. But if I did stop here, I would be at 1,650. If I stopped here, my number is 165. If I stopped here, I'm at 16.5. So I'm getting close. One more, I'm at 1.65. And I can stop there. If I went one more, then I would be at 0.16. And that is too small. And that won't fit in your range, I guess you could say, of what C is. So then you have 1.65. Now remember, we're not writing all these zeros. That's the whole point of scientific notation. So it's 1.65 times 10, and then you're going to count up how many times you moved your decimal. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And so you have 1.65 times 10 to the 9th. And that's your final answer. We can do it with something as small as 1,234. And then you would write that in scientific notation. So you would start with your decimal all the way to the right, and you're going to move it until you get to that number that's greater than or equal to 1 and less than 10. If I stop there, I'm at 123.4. So I'm going to keep going. And now I'm at 12.34. Keep going. Now I'm at 1.234. which is greater than or equal to 1 and less than 10. So I'm going to stop. So it's 1.234 times 10 to the third. And that's it. Notice these powers right here are positive. That means, well, not means, that's because the standard form number you're starting on, those numbers are greater than 10. But you can do this with just a number like 6. How would you write 6 in scientific notation? Actually, if you do this in scientific notation, it's going to take longer than just writing the regular standard form of 6. Because this number 6 is already less than 10 greater than or equal to 1. So you don't, and your decimal is here, you don't actually have to move the decimal. So it would be 6, because that factor C is already less than 10 greater than or equal to 1, times 10. Now, remember, your power tells you how many times you moved your decimal. But you didn't even have to move your decimal. So, is it a 1? No, because that tells you you would have to move the decimal once, and we're not moving the decimal at all. But you didn't even move it. So that would be 6 times 10 to the 0. Well, it's got to remember, anything times something to the 0 power is 1. So 6 times 1 would get me 6. Those are pretty tricky. So 6 written in scientific notation is 6 times 10 to the 0 power, which that actually takes longer, but you can still do it with numbers that are actually less than 10. All right, now we're going to get going on to example 2, and these numbers are going to be less than 1. I'm just going to squish that out and do that. So example 2 is still writing in scientific notation, but these are really small numbers. These are your numbers that are less than 1. Does that mean they're negative? That just means they're less than 1, but greater than 0. So example 2 in the book says the 2004 Indonesian earthquake showed the rotation of the earth making the length of day 0.0, blah, 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 a whole lot of zeros. Second shorter, write this number in scientific notation. Okay, so I have 0. 0.00000, oh, that's a 2. 268. Now we're going to write that number in scientific notation. Okay, so if I follow the same pattern as last time, what happens is if I move it to the left, my numbers just keep getting smaller. But we need this number to get larger. So we're going to now move the decimal to the right. And we're going to go until we get to that C number. Our factor is going to be greater than or equal to 1 and less than 10. So I'm going to keep moving. And right now it's at 0.268, which is still less than 1. If I move it here, I'm at 2.68. If I happen to move it one more time, I'm then at 26.8, and that's too big. So it tells you you're going to stop right there. And so you have 2.68 times 10, count them up, 1, 2, 3, 4, 5, 6. But if you leave it with a positive 6, that tells you your number actually got, this number right here is actually larger than 1. But this isn't. So this now tells you your decimal, not your decimal, your power is negative. So when you write numbers in scientific notation and the starting number is less than 1 and greater than 0, that means your power is going to be negative. Okay? So just think, if your number that you're starting out with is greater than 10, your power is going to be positive. If your number is less than 1, greater than 0, your power in scientific notation is going to be negative. Okay, I'm going to circle that one. Now I'm going to do another one. So let's go 0.05. We'll make it kind of small. So basically we're going to write 5 cents in scientific notation. All right. First thing you want to ask, is this number less than 1 or greater than 10? And since it's less than 1, that means we're going to move our decimal to the right because we have to get that number greater than or equal to 1. So we move it just once. I'm now at 0.5, but we need that larger. So I'm going to move it one more time, and I'm now at 5, which now fits in our range, I guess you can say, of less than 10, greater than or equal to 1. So we now have 5 times 10. How many times? 2. But if it's positive, remember that this number is supposed to be greater than 10. So remember, that's a negative. Okay. All right, now I'm just going to throw a problem out there. You don't know if it's example 1 or example 2. Let's go 683. We'll write that in scientific notation. So the first question you ask, is this number greater than 10? Or is it less than or equal to, is it less than 1, greater than or equal to 0? Since it's greater than 10, that means your power is going to be positive. So you're going to start with your decimal on the right and then move it to the left because we want this number to be less than 10. If I move it just once, I have 68.3. If I move it again, I then have 6.83, which now means this is less than 10. So you have 6.83 times 10 to the second. Now let's just double check if that's positive or negative. If I kept it a positive 2, that means 6.83 would have to get larger 2 more times, which would put me at 683, which that is the way you want to check that. If this was negative, that would tell you this decimal would have to go twice this way. And that's not what we started out as. So that's how you can check to see if your powers are positive or negative. Hopefully that worked okay. I'm only going to do a couple of them just because I have quite a few more examples to get through today. And we have example 3 coming up. Remember, our book is kind of tricky about what information it gives and what information it does not give. Oh, that stupid glare. So on example 3, it's using scientific notation. Now we're going to start using them in some real-life problems. It says an album has sold 8,780,000 copies. How many more copies does it need to sell to receive the award? And there's 4 multiple choice answers. I'm missing some information here. So don't forget to look at the pictures. And underneath the picture, you see a platinum album. And underneath it says an album receives an award when it sells 10 million copies. So the other piece of this information, the other piece of the problem that you need for this problem is actually in the picture. So don't forget to look at the pictures. Okay, so album is sold 8,780,000 copies. Oops. And it needs to sell 10 million. And the problem is asking, how many more copies does it need to sell? And they give you 4 choices as a multiple choice. Well, there's a couple ways you can do this. You can just find the difference between the two, get that answer, and then write in scientific notation. You can write these numbers in scientific notation and then subtract them. But you don't know how to do that just yet because that is actually the next lesson. So for right now, what you want to do is just find the difference, get that answer, and then put it in scientific notation. Okay, so we need to find the difference here. So we're going to go 10 million, yes, I'm doing this longhand, minus 8,780,000, and I'm lining them all up. Okay, subtract them down. Okay, 0, 0, 0, 0. Can't take 8. I'm going all the way over. So 10 take away 8 is 2. 9 take away 7 is 2. 9 take away 8 is 1. So we have 1,220,000. Now you're going to write this answer in scientific notation. I'm going to rewrite that just because it's a little messy. So 1,220,000. Write that in scientific notation, which is good because this will help us from example 1 and 2. So you're going to start at the same place. Is this number greater than 10, or is this number less than 1 and greater than or equal to 0? And hopefully you said greater than 10. All right. So that means the decimal starts here. And we're going to move that until you get to a number that is less than 10, greater than or equal to 1. So we're going to keep going. There's 1, 2, 3. Can't stop yet. Can't stop. Can't stop. I'm at 1.22. Can I stop? Yep. Okay. So I have 1.22 times 10 to the, now count it up. 1, 2, 3, 4, 5, 6. Check to see if your power is positive or negative. If this is positive, that means this number right here has to be greater than 10. If this power is negative, that means this number up here has to be less than 1, greater than or equal to 0. positive. And that answer is C. Okay, so that was example 3 from the book. And I'll be writing out the quick notes about if your power's this, what do you look for and all that kind of stuff like I did for yesterday's work. And I'll put it under the composition book section, topic, I think is what they're called, under your Google Classroom. Okay, so let's just use scientific notation. Now, example 4, we've got to really think about the grammar on this. And I really wish we were in class because we have a really good discussion about this. And then when kids argue about it, it's cool because I call it Mr. Campos. I'm like, can you help settle this problem for us? And it's kind of cool. I've called him the last bunch of years. So it says, we're going to use this real life comparing scientific notation now. So it says, example 4, the table shows when the last 3 geologic eras began. Order the eras from earliest to most recent. That's where we get in some trouble, not trouble, some good arguments. And I wish my arguer was here, Mr. Cabot. I know you would be arguing this in class, just because that's the kind of kid you are. Earliest to most recent. Now we're talking about, like, dead dinosaurs that are on the ground. So if it's the earliest, we actually are thinking about the oldest. Okay. The most recent, you want to think about that is my glare. You want to think about the most recent as the youngest and the earliest era as the oldest. So basically we're going to order this from oldest to youngest, also known as greatest to least. And I keep looking up just because it's so pretty out today. Oh, Bluebird Day. All right, here we go. So I'm going to write them out. Paleozoic. And it was 5.42 times 10 to the 8 years ago. But you see, this is when they began. Okay? And then the Cenozoic, then it began 6.55 times 10 to the 7 years ago. And the Mesozoic began 2.51 times 10 to the 8 years ago. And so I just wrote down the eras from the book. Okay. Couple things you could do. Write these all in standard form and then compare the numbers. But there's also a power of 8, a power of 7, and a power of 8. And you know that 8 is greater than 7. So remember, if we're going from earliest to most recent, we are actually comparing them from greatest to least. And since 8 is greater than 7, you know that this guy is actually the most recent. Okay? So what I'm going to do, we know that 10 to the 8th is greater than 10 to the 7th. So that tells you that the Cenozoic right here is the most recent. That is like the youngest, if you want to think about it. It's the least number. And then I'm going to compare, where's my 8s? These guys. So then I'm going to go 5.42 and 2.51. And what I'm going to do is I'm going to compare them using greater than or less than. And since 5.42 is greater than 2.51, that now tells me which era is the oldest. Okay? Since 10 is greater than 7, we know that Cenozoic is the least or the most recent era. Cenozoic. Okay? Took care of that one. Cross that one off because we're not using that anymore. And then, so then I have 5.42 is greater than 2.51. So Paleozoic is greater than the Mesozoic. So that now tells you which one is least, not least to greatest, from greatest to least. So that means Paleozoic, and then your Mesozoic. And there you have them in order from earliest to most recent, also known as greatest to least. And another one, oldest to youngest. if you had a hard time trying to figure out this comparison and how I did that and what I'm actually comparing, you can write these all in standard form. I'm going to do one of them for you. So 5.42, and we're going to go times 10 to the 8th. So 10 to the 8th, that tells me this number's, whoops, can't see that. Tells me this number's going to get larger. So if I move my decimal to the left, it's going to get smaller. So I need to move it to the right to get larger. And I'm going to move it 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Fill them in. This isn't my neatest work. And then I'm going to rewrite that. Oh, I'm going to rewrite so I can see it, because that is not very pretty looking. So 542 million. Yep. Make it a little bit nicer. And then I'll do the Mesozoic. So we have 2.51. We're gonna move it 8 times again. 1, 2, 3, 4, 5, 6, 7, 8. 1. And then again. So I just wrote it, moved it, and I know I put my board down. You guys couldn't see that, but I wanted to make sure it was kind of legible. And then you have 251 million. And then I guess I am doing all of them. 6.55 times 10 to the 7th. So we're going to go 1, 2, 3, 4, 5, 6, 7. Fill them in. 3. And we have 65,500,000. So you can see I just wrote the 3 of them in standard form. And then you can compare them. Which one is the largest? Well, there's the largest. There's the second largest. There's the third largest. Also known as from greatest to least. The words they use from earliest to most recent. So you can do it a couple different ways. Okay, it doesn't matter. And I think that's about it for today. When in doubt, guys, just send me a message and ask me for questions on Remind, verification, whatever. It seems like you guys have been doing pretty well on that. Extra credit question. It was the character that was on those ears that I held up. Who is that? And, so you get 2 points. What movie did that character come from? It'll be fun for all you Disney fans. Toodaloo.